the random process for a long enough time to conclude many of its statistical properties. So stationarity deals with over time, does the statistical properties or do the statistical properties of the random process change over time or not؟ يعني هل الراندوم variable هذا الآن at T1 and after 1 day does its average variance whatever PDF change over time or not? Does its mean change over time or not? العلاقة بين random process now and after tau seconds. هذه العلاقة does it change if I repeat the measurement tomorrow or after 1 hour? So stationarity deals with whether the statistical properties of the random process change over time or not. statistical property random process تتغير لكن statistical properties تتغير ولا لا؟ واضح يا شباب؟ Any question? No? Let's have an example. Might be more clear now. Show that given the random process x of t is a cosine omega 0 t plus theta. Show that it's a Whiteson station. If it is assumed that a and omega 0 are constants, so the amplitude and the frequency are constants, however the phase is uniformly distributed random variable over 0 to 2 pi. And this is a typical phase, we call it modulated signal. So this is not something that we don't see. This is typical in communication signal. So basically the amplitude of the carrier, this is the carrier, this is the amplitude of the carrier, the frequency of the carrier is constant, the amplitude is constant. However, the information, the randomness, your voice is carried over the phase. Okay? So we want to show that it's Whiteson stationary. What do we need to do? Shabab? To show it's Whiteson stationary, what do we need to show?
The mean is constant.
Yes. The mean expected value of x of t is constant, doesn't depend on time, and
Coloration depend only on tau.
yes, so base t plus t at t and at t plus tau only depends on tau. So t is irrelevant. When do you make the measurement? Doesn't make the autocorrelation function different. So we'll see. So x of t is this, a cosine omega 0 t. Well, don't always remember what is constant and what is random. Theta is random here. And the PDF of theta is, as it's mentioned, uniform from 0 to 2 pi. Here comes your knowledge from chapter 2, chapter 3, and so on. Now the expected value, which is the mean of x of t, is simply the integral over theta, because theta is a random thing only, from 0 to 2 pi, a cosine omega 0 t plus theta. And this is the PDF of theta. Now, if you integrate a cosine wave for a complete period, you get 0 always. Okay? So this is the first condition, check it. The second condition, the autocorrelation function at 2 time instances, t and t plus tau. Now this correlation between the random process at t and at the delayed version, t plus tau, does it depend on where do you make the measurement at t, or it only depends on the time difference, tau? If it only depends on the time difference, so it doesn't change as when do I make the measurement, then this is a Whiteson station. So let's see, its expected value of x of t plus tau. So it's a squared cosine omega 0 t plus theta, cosine omega 0 t plus tau plus theta. So I have cosine, I can write it as half cosine the summation plus cosine the difference. And remember, I am making the expectation with respect to what, يا شباب? شباب, the expectation, the averaging, with respect to what? نعم. What is the random variable here?
Theta.
Theta. So basically you can see that this is cosine omega 0 tau. Is it random or constant? It's constant. So I take it out. And then I am left only with the expectation of cosine 2 omega 0 t plus omega 0 tau plus 2 theta. And if you do this, you will find that this is 0. Because again, you are integrating a cosine wave over the full period, 0 to 2 pi. You will see that they cancel each other and you get 0. Check it out. And you end up with a squared over 2 cosine omega 0 tau. So what do you think? Does it depend on t?
No.
No, it depends on tau.
Exactly. So basically it's like equal to only a function of tau. So it's checked. So basically x of t is White's station. تمام يا شباب؟ Let's see another example. A random process x of t equals 3t plus b. b is uniformly distributed, random variable from -2 to 2. Determine the mean and the autocorrelation function of x of t. Is x of t White's stationary? And justify your answer. So let us see. I will say x of t. What does it look like? So if I want to plot one time function, بس عشان نساعدكم تتخيلوا. خلينا نرجع اللي قبل كده هذه. If I want to plot one time function here, this basically depends. Theta is the random, so it can look like this, right? Or it can look another delayed version. Or it can look like this, right? So basically it's the same cosine except that the delay is the difference, is the random here. Okay? And because of that, you see that it's the statistical properties are the same. They don't change over time because the signal keeps repeating itself. The only difference between one sample, one realization and the other is when does the cosine start. تمام يا شباب؟ بينما هنا let's do the same thing. Plot this. It's 3t plus b. b is what here? ايش b يمثل يا شباب؟ b is uniform. الشيفت whether shift in y ولا x؟
اكس.
shift in x ها؟ يا شباب.
Down دكتور here, right?
كيف؟
Shift up and down, right?
Shift
Vertical axis.
Up, vertical axis, exactly. So basically, for a certain value of b, خلينا نقول b equals 0, you might end up with something like this. It's a 3t, so السلوب شوية عالي. For another value, it might be like this. خلينا ناخذ نفس السلوب المفروض. For another one, it might look like وهكذا. Now, does the طبعا تلاحظوا هذه تكبر جالسة مع التايم. And so on. What do you think? The mean, the average, will change over time or not?
No.
Why?
We still have the same signal, the same properties.
لكن الآن نشوف هذه يعني. بس خلينا ناخذ time here t1. شباب أبغاكم تفهموا الفيزيكال meaning. ما أبغاكم بس تسووا معادلات. ترى ممكن نمشي على المعادلة ونخلصها ونمشي. I want you to understand physically what does this mean؟ T1 كم الافرج حق السيجنال هذه؟ خلينا ناخذ هذه نيجاتيف هنا وهذه نيجاتيف اكثر وهذه شويه almost قريب من الزيرو، تمام؟ فعندنا تقريبا نيجاتيف نمبر صح؟ بينما خذ هذا T2 this has a large number this has a large number this has a large number a larger number and so on. هل الافرج هنا at T1 and at T2 the same؟
No.
واضحة إنه السيجنال at T2 is growing over time لأنها 3T x of T depends on T. So كل ما يكبر التايم كل ما أطول أكثر بعد هذا at T3 I expect that the value of these functions becomes very large. صح ولا لا؟ شباب is it clear to you؟ شباب
بس دكتور.
So basically you can see that the average which is the least to verify depends on time. فأنا ممكن من واضح من شكل السيجنال it's not Whiteson stationary. It is not. لأنه الافريج يتغير مع الوقت فما بالك الأشياء الثانية. بس anyway هو he asked for this. If he didn't ask you can do it this way and explain your answer. طيب. So let's see what is the mean here. It's expected value of x of t. Expected value of 3t plus b. And I know that b is uniform from -2 to 2. So the expected value of b is what? شباب expected value of 3t plus expected value of b هذه هي كده 3t plus expected value of b. What is expected value of 3t? Any random here in 3t?
It's just a constant.
It's a constant, so it comes like that, like as it is. What about expected value of b? Uniform from -2 to 2. What is b? It's uniform from -2 to 2. What is the average of this?
0.
0. So basically you have 3t. This is 0. طيب. Now let's see Rxx of t and t plus tau, which is the expected value of x of t plus tau. I simply just put x of t and x of t plus tau. And then I open up. So I have these terms. Now any term without a b is constant. So it comes like as it is. So, and I have here expected value of b squared. What about anything with b? Its expected value of, it's, for example, this one, 3t multiplied by expected value of b. But what is expected value of b?
0.
0. So basically I have 0 here and 0 here and 0 here. And I end up with only 3 terms. And for the uniform, if I calculate the expected value of b squared, I will get it's 4 over 3. I don't need to remember any equation here. I simply average the expected value, sorry, I write b squared multiplied by the PDF and I average from -2 to 2. I do this and I calculate, it's 4 over 3. So the autocorrelation function is this. Does it depend on time?
Yes.
So basically, it's not Whiteson stationary. So we have the mean is not Whiteson stationary. The mean is not constant. The autocorrelation function depends on time.
Doctor, if one condition is not satisfied, this enough to be not wide
Yes.
stationary.
Yes.
Right?
If one condition is not satisfied, this is not a Whiteson stationary. Okay. But here, this is a practice question. I did not only ask you, is it wide or not? I asked for the details here. طيب. So let's talk about the correlation functions. The correlation functions هذه مهمة جدا. In chapter 7 we will talk about spectral characteristics. we will define what we call power spectral density, and we will find that this is the Fourier transform of the autocorrelation function. So we need to understand what autocorrelation function means. autocorrelation function زي ما قلنا بالذات الآن خلينا نتكلم على wide sensation. So here autocorrelation functions of wide sensation processes. First of all, it only depends on tau. So basically it's a one-dimensional function. I can plot it versus tau, a time delay versus tau. The first thing is that the autocorrelation function cannot exceed its maximum, which is at 0. What is Rxx at 0? So what is Rxx at 0? No answer?
5.
The second momentum of
The second moment. It's expected value of x of t squared. Right? ليش? What is Rxx of 0? It's expected value of x of t plus what? What is tau here? Tau is 0. So it's expected value of x of t squared, which is like, as we will define later, it's basically related to the power of the signal of x of t. So the autocorrelation function is always less than or equal the power of the signal, the average power of the signal. هذا الشيء. الشيء الثاني does it physically make sense؟ الآن what I'm trying to do here أنا جالس أشوف الراندوم بروسيس. Okay. The correlation between the random process now and after tau. Right? So now this says that at any tau, if I'm looking at certain time t0 and I'm shifting with tau, so I start with at t0 كم الكورليشن بين الراندوم بروسيس ونفسها اللي هو expected value of x squared. هذا حيعطيني رقم which is Rxx of 0. هذه الراندوم بروسيس مع نفسها الكورليشن الريليشن شيب الراندوم بروسيس مع نفسها at the same time. Now as I shift tau, I'm looking at the relationship between the random process now and after certain tau. And as I shift tau, I'm looking at the relationship between the random process now and after another tau وهكذا. كيف تتخيلوا يكون الراندوم بروسيس الاوتو كورليشن فانكشن يكبر ولا يصغر as tau increases؟ يا شباب الراندوم بروسيس on average مع نفسها الآن وafter 1 second مع نفسها وafter 1 minute ايش تتخيل أكبر يكون؟ العلاقة بين الراندوم بروسيس ناو بعد 1 second ولا ناو بعد 1 minute؟ What do you think is larger? Should be larger. Which one? After 1 second ولا after 1 minute? شباب لسه رمضان ما بدأ ترى. ايش بتسوي في رمضان؟ شباب معي؟
Yes,
Do you understand anybody understands what I'm saying? ايش اكبر العلاقة relationship correlation between the random process now at t0 and after 1 second ولا after 1 minute؟
after 1 second.
after 1 second لأنها قريبين من بعض. مع مرور الوقت السيجنال have more chance to change over time. انت صوتك الآن وانت تتكلم أنا البروجكت كله about audio signals. الصوت الآن after 1 second have high correlation لأنك انت مثلا تصارخ الصوت عالي ما ينزل خلال 1 second ياخذ له وقت لما ينزل. الناس لما تصارخ ما تسكت في خلال 1 second لكن بعد 1 minute ممكن يهدى شوي. تمام؟ So basically as time passes the relationship between the signal and the signal, the delayed version, goes in general decreases as time passes. عشان كذا the relationship أو the relationship with the signal with itself is the largest اللي هي RxX0. And it decays. طبعا it doesn't decay as one shot. ممكن زي كذا تطلع تنزل تطلع تنزل لكن average it goes down. Okay. مو شرط انها it's not a decaying function لكن over time it goes down. Over tau it goes down. It goes down. هذا أول شيء. ثاني شيء الآن does it make a difference if I take the tau 0 here and I take tau here ولا العكس tau 0 t 0 here وتاو هنا وأمشي بالعكس؟ ما تفرق. اوكي ما تفرق. ليش؟ لانه انا ما تفرق بين معي اقيس تي 0 امشي يمين ولا امشي يسار. It should give me the same result. And which makes the random process or the autocorrelation function at minus tau equals the autocorrelation function at tau. So it's an even function. إذا أعطيتك function not even, this is not a valid autocorrelation function. واضحة هذه يا شباب؟ So our property, the autocorrelation function has maximum at 0 and the maximum equals the expected value of x t squared, expected value of x of t squared. The second property is it's even. The third property is if stationary and ergodic. We'll talk about ergodic by time after 2 lectures maybe. And no periodic component, then as tau goes to infinity, what does tau goes to infinity means? Means I am looking at Rxx of infinity. ايش يعني؟ It's expected value of x of t and x of t plus infinity. What does this mean? I am looking at the relationship between tau, x of t now and after very, very, very long time. يعني اليوم وبعد أسبوع. إيش رأيكم؟ في correlation؟ في علاقة؟
Almost no correlation.
Almost no correlation. So basically this is almost will become or will approach. خلينا ناخذها كذا. خلينا نشيل التاو. I keep tau بس. This as tau goes to infinity ايش توصل هذه؟ تصير expected value of x of t multiplied by expected value of x of t plus tau. And this happens as tau goes to infinity. Multiplied, ما في correlation, which makes it ايش؟ x of t average multiplied by x of t average. ليش؟ لأنهم ergodic. الergodic حنتكلم عنها بعدين بس keep up with me. Which is expected value, which is the average square. So as tau goes to infinity, العلاقة بين the random process now and its delayed version becomes almost no علاقة, which makes the expected value separable into 2 expectations, which makes it 2 averages multiplied with each other. Okay, شباب? The last property, if x of t for stationary and x of t has periodic component, مثل المثال اللي تكلمنا عنه فوق, الكوساين ويف. هذه x of t has periodic component. واضح انها تتغير كوساين. So basically it keeps changing as cosine. هي random لكن it keeps changing في periodic component. Then the autocorrelation function will have a periodic component also with the same period. So basically x of t is stationary and periodic component. Rx x of tau will also have periodic component. حصير شكلها كده. لو تلاحظ هذه doesn't decay to 0. It doesn't go down. It goes down and up and down. ليش؟ لأنها has a periodic component. Any question يا شباب؟ 7 example. See. طبعا يا شباب هذا الكلام مرة مهم لأنه بعدين chapter 7 will be built upon it. Chapter 7 اللي هي spectral characteristics is built upon all this. So given the autocorrelation function of a wide scene stationary. So he's giving me this is a wide scene stationary. Find the variance. وأعطيك أنا autocorrelation function. Now I use the properties. I have two properties in here I can use. At tau goes to infinity, the autocorrelation function approaches the mean squared, the average squared. Okay? So at tau goes to infinity, this whole thing goes to 0. And I have expected value of the average square equals 25, which makes the average either 5 or minus 5. Now the second information is R xx at 0 is equal to expected value of x squared. So the variance equals expected value of x squared minus the average square. I have this. This is 25. Expected value of x squared is rxx at 0. So if I put 0 here, what do I get? 25 plus. Shabab, what is rxx at 0? Send it
29.
over 29. It's 25 plus 4 because this is 0. The denominator tau squared will be 0. So 25 minus 9 equals 4. So I know the variance equal 4. So from the autocorrelation function measurement, I can calculate the average value and the variance value from the information I know, from the properties of the autocorrelation function. Another example. هذه الحصة كلها examples. Find the autocorrelation function of y of t given that x of t is wide scene stationary. So y of t equals x of t multiplied by cosine. So basically x of t is like, think about it as an information modulating a cosine wave. A cosine wave has a random phase with a phase that is uniform between minus pi and pi. So x of t is my information. I multiply it by cosine with random phase. And I get the modulated signal, which is y of t. Okay, this is a typical AM modulated signal with random phase. Now, he gives me the autocorrelation function of the modulating signal here, x of t. So x of t has autocorrelation function rxx of tau as this, and it's wide scene stationary. I need to find the autocorrelation function of y of t. واضح السؤال يا شباب؟ So basically just proceeding with the details. Ryy of t and t plus tau is the expected value of y of t multiplied by y of t plus tau. I simply just replace y of t with x of t cosine omega 0 t plus phi, plus theta. So I have x of t cosine and x of t plus tau cosine, and I have t plus tau here. I take everything related to x of t alone because x of t and phi and theta are independent. So any expectation that have both of them, I can just separate it. So I have expected value of x of t plus tau, and expected value of the cosines. Expected value of x of t plus tau is Rx x of tau, by definition, which is given to me. While cosine is half cosine the summation plus cosine the difference, as we did before. Now the cosine the difference, which is omega 0 tau, is not a function of theta, so it's constant. It goes down. While this thing, average of cosine over one period is 0. So I have half Rxx tau cosine omega 0 tau. So it's half exponential, which is Rx e2 minus a tau multiplied by cosine. هذا هو شكله. Exponential, which looks like the envelope, and it goes inside the cosine. زي ما قلنا, it's periodic, right? Y of t is periodic with period omega 0, with frequency omega 0, or period 1 over omega 0. So the autocorrelation function is also periodic with the same period. زي ما انتم شايفين شكله كده. Any question? شباب.
Yes, doctor.
تفضل.
No question, I mean.
طيب ممتاز. Others. شباب, the random process is a very important part of your curriculum. يعني, and I don't want you to relax at the end of the semester لأنه عليكم ضغط عالي. الله يعينكم, لكن you need to pay attention. الله يخليكم. This is an extremely important part of the EE315. Okay, and you need to pay attention to it. تفضل. الناس اللي حيكملوا في ال communication, signal processing, control, these are very important subjects. حتى اللي ما يبغى يكمل فيها, still it's very important for your way of thinking. زي ما قلنا, توسع مدارك تفكيرك. Yes. في أحد كان يسأل؟ طيب, cross correlation and its property. Again, هنا for wide sense stationary. يعني تكلمنا قبل كده على non wide sense stationary. So I think for all هذه آخر شيء بس for wide sense stationary. So Rxy of t and t plus tau at 2 time instances is the expected value or the relationship between x of t and y of t plus tau. X of t and a delayed version of y of t. يعني أشوف السيجنال x of t الآن والdelayed version of y of t after tau seconds. كيف علاقتهم مع بعض؟ If they are jointly wide sense stationary, we can write it as Rxy of tau. هذا حتصير تعتمد على tau بس. If I have orthogonal processes, then this cross correlation is 0. If they are independent, then I can always write expected value of x of t, y of t plus tau as the product of the two expected values. If they are independent and wide sense stationary, then each average of this will be constant, right? So the cross correlation function will be the product of the two means if they are independent and wide sense station. واضحة يا شباب؟ So basically, the cross correlation function, if they are independent and wide sense station, the cross correlation relationship will be constant, which is x bar y bar. هذه هي الكيس كده. Okay, if independent and wide sense station constant ما تتغير لأنه mean of both is constant because they are White stationary, and they are independent, and hence the autocorrelation function doesn't change over time. Simply ما في علاقة بينهم باختصار. طيب, let's talk more about if they are jointly White stationary. If they are jointly White stationary, then Rxy of minus tau, يعني خلينا ناخذها بالطريقة هذه. If this is the signal x of t and this is y of t, هذا I'm plotting only one realization. If I'm looking at now العلاقة بين the signal x of t and y of t. Okay, so basically x of t now and after tau seconds. So this is t0 and this is t0 plus tau. هذه نفس العلاقة if I put t1 and t1 minus tau. صح ولا لا؟ If I put t0 and t0 plus tau في y, نفسها لما أكتب t1 and t1 minus tau for x. So basically Rxy minus tau is the same as Ryx tau. لما أغير يعني باختصار هذه عبارة عن إيش؟ expected value of y of t x of t plus tau. تمام؟ الآن إذا غيرت الترتيب أجيب x of t قبل وال y of t وبعد تصير Rxy. أوكي؟ واضحة يا شباب؟ من الجراف هنا. The second thing is the absolute value of Rxy of tau is always less than or equal what we call the geometric mean. Rxx at 0 multiplied by Ryy at 0 under square root. And it's also less than what we call the arithmetic mean, which is Rxx at 0 plus Ryy at 0 and taking the average of them. دائما ال Rxy of tau is less than these two. شباب واضحة السلايد هذه؟ Any question? طيب send me that everything is clear. الله يخليكم. Send me over private chat the word clear. Just to see who's here and who's sleeping. If you don't reply, you are absent. You are not here. إن شاء الله الشباب معنا أجل. طيب شباب, I hope that it's clear because as I mentioned, these are very important. Chapter 7 is all built upon all this. شباب, send the word clear. If you don't send, you are absent. طيب. I think time is up. So next time, inshallah, we'll go over this example and we'll continue with the Gaussian random process and probably the Poisson random process. So I will stop here because there's no time to complete this example.